Good morning, everyone. Today we continue with the table, but in a new sense. So last time, let's do the little recap. Last time I asked you a couple of questions to conclude yourself, find and summarize whatever you can. And the one thing that most of you said that probably if you had 1,000 participants in a questionnaire, and so that would multiply the data by how much, that it would be harder to conclude stuff just using the table. So what do we usually do? We usually do then, and this is going to be in the next chart, is today's lesson is going to be basically visual representation of data, visual presentation of data. So what do we do? Before I go into the visual presentation, we have to summarize things. Basically, we summarize things in new, simpler tables. For example, like here, where I have said, I want to look at the gender. I specified the genders that we have in the table, so that are male and female. We don't have anybody of the other. You can also put other. And this was 0 in this case. And you use specific Excel tools. In this here case, you can use any other program or software to also represent data, or visually, or in a table, or wherever you like. But Excel is something that you will use next year in school, in informatics. So I'm also using it here. Now, the tables that we do here, and how do we do them? Well, softwares like Excel give us options to count for us, so we don't have to count. You don't have to count. We have 1, 2, 3, 4, 5, 6, 7, and so on. Well, it can count for us. Now, I'm not going to ask you to know how to do it, but I'm just going to show you, so you have an idea for the next year how the things are done. So, for example, we started with the male, and in the male category, so basically these are the categories, and how many of each category do we have in the questionnaire. So for the male category, we have 12 of them. Now, when I clicked on this, I can double click so I can go inside, and I'm going to show you like this. So if you want to ask something Excel to do for you, you usually start with equal sign at the beginning, so it knows that it is going to have to do something for us. And this is basically called formula in Excel. So the formula that I'm going to use is going to be count if. Basically, this is what it is. Count count from this here column all of those that are male. So count if here are in this column males, basically. This is how it works. And it counts for us. Oops, I'm going to escape. It counted 12 people as male. So same thing is for the female. I'm using again this count if function. It's called a function. And it counted, Excel counted for us that we have altogether 15 females in this questionnaire. So we can also say this is for this class, 12 males, 15 females, and none of the other. One more thing about it, and I want to specify now for this here function COUNTIF. COUNTIF is going to be most commonly used in statistics. I'm going to show you this example soon again. And it helps a lot. It helps a lot to summarize things, to simplify it as much as possible. So now instead of having altogether, having a full column, imagine there was 1,000 people here and the column would be huge and there would be 1,000 answers here. And we change it and we represent it with this small here table. Nothing specific. It's not anything special. It's here. Okay. So now we simplify things. Now this is not visual representation yet. I'm going to go through the visual representation yet. Go through the visual representation once I'm done with these tables explaining how what they do. Okay, the next table that I want to show you is the height table, and just showing the minimum and maximum value, or minimum height and maximum height in the class. And I said here range. About the range itself, I'm going to talk more in future lessons. Not yet. I'm going to. It appears here, so I'm just I have just put it here so that we are okay with that. So instead of looking into the height column here, instead of looking into it and trying to find who is the minimum height like you had to do it in lessons before, well, this time, again, Excel can do it for us. In this here case, if you write equal, so each time if you write equal, again, Excel knows that it has to do something for us. And basically, min. And you pick a column in which you are looking for the minimum value, and it will show that minimum value. And it is 157. Same thing is for the maximum value. You just equal max, and it will find the maximum value. As simple as that. So this is how it works. And now we know the minimum and the maximum value for the height. Now, one thing about it, why did I want to do it? Why did I want to do this table? Well, I want to see how many people do we have of each height between these two specific heights. So instead of going from 0 to, let's say, 200 centimeters, I can now go through only heights that appear in this column or the table itself. I can go only through those. And this is what I've done in the following table. So this is the following table with this. So basically what I've done, I have counted, or I have written down all the numbers between 157 and 192, and then counted for each of these, for each of these, how many do we have of this individual height. Now, when you have 27 participants in a survey, well, there's going to be a lot of zeros. There is going to be a lot of zeros. Sometimes we are going to have ones, twos, threes, or even fours. And if you had 1,000 participants, well, there would be a lot less zeros in this here table. So now, what did I want to show you in this here two tables? That sometimes when you want to represent the data, you can use multiple charts or multiple tables, so to say. Charts are going to go after tables. Let's stick to the tables. So we used actually here two tables. First was the range of heights, so that we know that we have between 157 and 192 heights. And the second table is then counting how many of each height between these two values do we have specifically. So this is another example. And third example that I want to show you in today's lesson, and then I'm going to go into the fourth and the last one, and I want to show you how it's done, and this was all prepared before, is, for example, returning to school, see how many answers of each do we have. So this is basically this here column and how it works. The thing I've done here, I have written down all the possible answers that are given. So yes, no, and maybe. And then similar to the gender or even the height, I've counted each of the possible answers and how many do we have them. So now we have again simplified a specific column or a specific answers. We have simplified. And well, why is statistics considered as part of mathematics? Let's talk about this for a second. It's not because you can use or ask people numerical questions, like, for example, height or grade point average, or even how hard is math. It's actually, the answer is a number in a sense. No, it's not just because of that, because in other sense, as I talked about statistics so far, we can also use, for example, dates. They are numbers, but they're also their own mathematical form or number form. Then we can use words. We can also use letters. For example, if I've just written down F for female or M for male, you can also use letters. And you can use multiple words or even maybe sentences. I haven't given you this type of question where you can write down the answer as a sentence. But for example, you can ask that or interpret it as your name and surname question that was. It was basically a sentence where you write down your name and surname. Now, this is not, of course, here. We have reasons for that, and I already explained them. Okay, now let me show you one last example, simple example. These are all simple tables. We're going to see in the future, maybe we can look at multiple stuff together and so on. But for now, I'm just going to use the simple stuff so that we know how we use statistics or how do we interpret certain data in the table and simplify it and then conclude something from that. Okay, let's go with the how hard is math. How hard is math? So we can go through the questionnaire, and in the questionnaire there were answers from 1 to 5, from impossible to easy. So there are a couple of ways we can do it. So how hard is math? I'm gonna make a new table. How hard is math? This is going to be a table for itself. Now, the categories of the answers are basically 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5. I have counted them. You're going to find out in the future that there are simpler ways to count it. And I'm going to, well, let me show you. It's not that hard. So if I just put values 1 and 2, and I know it's going to have to continue on, I can go into top right corner, and you see how the cursor changes into a plus sign. Well, if it does that, you click and hold the left click, and you can see that to the right, you see values 5, 6, 7, 8. So if I drop down the key here, it will put value 8, but here we have 5. And this is a simple way, and this is basically what I've done in this here table. I didn't put all these values manually. Okay, so let's go through this. I want to count how many ones do we have in all of this. So count equals. I want to tell that to Excel. So count if. It, as you can see, it will already show you possible function that you can use. So if you are not certain about the specific function in Excel, you can start writing down, and then you can see if this function exists. If it exists, it will be shown here. Okay, open the bracket, the range. It asks you the range. The range itself is going to be from these here values. Okay, or this is the range basically where you look for this value. And criteria, well, this is the criteria that we're looking for. There you go. We have 0 of ones. Let's continue on. Count if, range again. There we go. And criteria. So how to arrange stuff in a way like that we know this is the range and then it's criteria. Let me show it. Well, we can use, like you can see in the function itself, it says count, range, and then criteria. So we specify each for its own. And also when you do it like this, well, you're gonna see that each is in its own color, basically. Okay, we have 2 with 2. Then we can continue on. Count if, range, and criteria. And then for last 2. Now this is something that I'm not gonna ask you that you know how to do. This is just to show you. Next year, you're gonna need to know it, but not in math class, as it is. But it's useful. It's all of this is useful, and once you finish high school, whichever work you're gonna do one day, there is a high probability of you using Excel for specific tasks. Okay, now we have another table. Let me now just go through this a little bit and see if I can do anything more. Let me just put it into the bracket so that we know specific tables now for each of these. So we know, by the way, I'm going to give you this whole thing. I'm going to give you everything from this, so don't worry about it. Okay, now we have these answers here. And now one more thing is how we visually represent the data. Now, what I wanted to go through, what is the goal of this here lesson? It is to show you that we can simplify given table. We can simplify it to, instead of looking through the whole data, we can just look at the simple stuff and count things, and then we'll be able to represent them. Now, this here table, again, is not that easy, and it's not that simple in a way, and it has its own issues, but it's also a certain tool that we can use. And these last two are, again, simple one. As you can see in so far, I have used in 1, 2, 3, 4 charts altogether, countif function to count for us. Only chart that, or only table that didn't use the countif was for the minimum and the maximum value, basically only for that. Now, before I go into the second part of this lesson, one more thing. Well, here in the use of online, use in online school for laptops, computers, smartphones, tablets, and so on, where here it becomes tricky. And I'm going to show you that in the next lesson itself. Maybe we should separate all the given data. Basically, we have three things in together. For example, in this here answer, you have both computer, smartphone, and tablet. Well, maybe it will be hard for software to represent or find all of these as separate. Then we have to help it by separating ourselves. And another thing is, as I already talked before, is about the color. Well, computer or AI or whatever that is looking in this data and helps you find certain things. Well, maybe it doesn't know the difference or it sees the difference between navy blue and even this small letter blue. So maybe we have to unify things and then tell computer, okay, find me this in a certain way. And I'm going to go through it in one of the future lessons. Okay, let's go back and let's go into the second part of this lesson, because this lesson is basically visual representation of given data from this table. And now that we have these smaller tables, these tools basically for us, these are going to be the tables that are going to help us to visually represent given data. So how to do it simple in Excel? Well, once we have this, for example, gender, we select the whole table, we select this whole table, and then we go on the insert, and we can go as simple as possible and let Excel recommend us the chart. I'm going to click on it. There we go. And this is the chart itself. Now we have a couple of possible charts that we can use in this here case, and this is awesome. This is awesome, and I'm gonna use this. I'm not gonna go like, if you want to put in the chart itself, you click OK, and you have it. You have it, okay, and it shows you here. I'm not gonna go through that. This is gonna be for the next year more, but I just want to go through the types of tables that are given. Now, first table that is going to be most commonly used, and I already told about that, most common chart is going to be the column chart. And this is the first one. Oh, clustered column. It's already said here in its name. Now, what does this column chart visually represent? It visually represents number of specific answers. For example, how many males there are and how many females there are and how many others do we have in this questionnaire. When you look at the second type, And why is a column chart used the most? Well, it doesn't just show you the number of individual answers, it also shows you a relationship between them. For example, we can see that we have in this here chart, even if you don't look at the numbers, you can see that we have less males than females, and that we have no others in the questionnaire. Also, we can see that there is, you can see that you can feel the difference is big. You can feel the difference is big, but this is something that is the big issue with the column chart. It's mostly misused and used for false news, used for false advertisements, used to represent things as they shouldn't be. Now, when you look at it, and it was a news article, it would be like, oh, there is a lot more females than males, blah 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 blah, a lot more. Well, when we look at the class itself, there is 3 more females in the class than males, and it's not that huge of a difference if you look at it that way. But they can then even go further, where they can make the difference even huger if they stretch the column, if they stretch it higher columns, so the difference becomes bigger, so to say, because of it. And then it's used to mislead people into, oh, there is much more females in this class than there is males, so to say. Now, where they cannot cheat that much, or where cannot they lie, is using the pie chart. In a pie chart, we can sense the difference. We can sense the difference, and you can see now, well, yes, there is more females than males, definitely. Yes, that's for certain. But when you look at it, it's a little bit more than 50% in favor of females. Now, I talked about percentages here. If you read here below, you will see that that it actually uses the percentages of each gender in this here case, and the pie chart itself only shows us the percentages, or which you have in the whole, so in the whole class of 27, which are represented more or less, so to say, however we want to go through it. Now, pie chart itself is more fair if you want to compare stuff as it is. But what it doesn't say, and there is that is its own issue, is it doesn't show you how many exactly males and females there are. Now, if you want to use it on a number of 1,000 people, well, it will be good representation in a way, because it will tell you then, oh, in this in general we have more females than males as it is, and it will be more common and better in the general sense. And if you wanna be as good as possible and look at all the things, you're gonna combine both the column chart and pie chart. This is going to be called pie chart as itself. As you see, it's a pie. Now, I hope you sense the differences. Write the differences down between all of these, right? So as I'm going through the lesson, you write things down. So column chart tells us exact number of each gender, in this here case, or whatever we are looking at, while pie chart tells us the percentages of each category, so to say. Yeah, better if you use category. And we can lie through column chart. We can represent one category is far greater than the other, while in column chart we cannot do that. But column chart, the pie chart has its own issues where it doesn't show you exact number of each category. Now, the third here given is the bar chart or row chart. I'm going to use more as a row, and there's no basically difference between these two. They are the column and row chart equal, but sometimes it's easier to look at the row chart. While, for example, in the height, chart that I'm going to show you later, it's probably going to be better to use the column one, but because it represents the actual height, so to say. Like there are some psychological also aspects to the visual representation. And there is one last here that is given to us, and that is the funnel chart. Now, I'm not going to go through it. It is more common in higher statistics. And well, if you look at it, you can also represent it yourself, what is going on. It doesn't just show numbers. It's like let's say it's a combination of the pie chart and the column chart, where it says, as a column chart, it says how much of each category do we have. And in another sense, it shows you from the pie chart, well, it shows you the percentage, who has greater percentage, who has lower percentage, even it doesn't show exactly. But yeah, it's not that common and it's not used that often in this here sense. It's gonna have its own use in something in the future probably. Okay, so I'm not gonna put anything in, I'm gonna go with the next thing. Okay. As we go with minimum and maximum, there is no visual representation of that, and we don't have to go through it. It is just a tool that we have, or I have done, so that I know which heights do I have to look at specifically, and this is going to be with the table beneath this, where we have the heights of all the students given, and now we can look at how many of each do we have. Now I've selected this table, now I can look at the chart which represents it. Now, I'm gonna skip a couple of these for starters, and I'm going to go with the third chart that is recommended. And this is the chart that is, again, column chart. As you can see here, we can also use it as a row chart, but row chart is not that used that often specifically for the height. Yeah, this would be probably the better, and this is a psychological thing in a way, in a sense. Okay, now here we have the representation. We can see that there is now there is a problem with this. We don't have all the values represented because there is so many of them between 157 and 191, and that is another issue. Now there is a way you can fight it in a sense. When you make this chart, then you can go through specific categories, and if there are no answers to the specific categories like 159, 159, 160, and so on, then you can put them out of the, like, so to say, equation, and then you don't look at them, and they're not going to be shown, and it's going to be simplified in a sense. But that is then called manipulation of the data, and it's again something that is going to be misused, and it's misused a lot. Because it then shows you can also say, you can also exclude from the chart 165 then, and it won't show you that we have 4 people in this class with height of 164 or 165. Okay, so that it becomes an issue, and it can be misused. And if you think it's not misused a lot, well, think again. Okay, there is a lot of false news, and usually use charts to mislead people into believing us in things that are not correct. Okay, so this was again with the column chart, and let me show you now a line chart. Now, line chart is not good representation of this specific data, but let's think about it in a sense that there is progression of things like people. It's going to be used more in a sense where we have a certain progression of stuff. For example, instead of looking at the height, here was the time, progression of time. And let's say in the morning, we felt like this, during the day, we felt like this, and in the afternoon, our feelings went up we felt really good and then really bad, blah, 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 in this here case. So, and there are going to be some certain specific cases where I'm going to show you this line chart. Well, the line chart itself is not good here. Why is it not good? And I'm going to show you, and I'm going to tell you why. So, if we would look at the specific height, and I ask you to use the integer values themselves, and let's say that we have nothing in between, so we don't have anyone who is between 164 and 165, the decimal value between one exactly integer. Well, this here line basically shows us there is infinite values between them, and there can be infinite people with between values of this. And yeah, line is always only used when you have infinite values in between. Okay, only then. Like we use the line in coordinate system, where you have every real number on the x-axis, so to say. Basically, this is the x-axis, this is going to be the y-axis. And this is simple for it. The charts themselves, like line and the line, column, or the row chart, are simplified versions of coordinate system and use of the coordinate system. And then we have this here, histogram. Histogram is used when you want to look at combine things together, when you want to combine things together in certain categories. Now, when you look at like this, for example, look at this here, it goes to 201, and we don't have 201. It extended, the histogram extended the values that we're looking at, and then it combines. So there is, let's say, what we can read from this is that there is 12 people between heights of 157 and 168, including these here values. Now we know the intervals themselves. Then we have 10 people between 168 and 179, and so on and so on. And it combines things. And it can be also helpful at certain times. Well, it doesn't show you exactly of specific height, how many people there are. But when you combine things together, it can tell you, well, between these heights, we have 12 people. Between these, we have 10 or 11, and so on, and then 2 in the end. And this is, again, nice chart in a sense. What it can help you out with, and this is, again, misuse, it can help you hide the data. Can help you hide a certain data. For example, when you look at this column chart, well, there is a lot of people missing here, or we don't have anyone between 157 and 165 between those values. We don't have anyone, and then suddenly, boom, there is 12 people, because it included in all the way to 168, and 168, we have a big spike here of people, and then it included it and showed like we have most people here. So this is, again, some way of misuse. And I want to show you that. Why do I want to show you that? I want you to become statistically literate. And there is, when I look at the news on television or internet, doesn't matter, I can see how much false data it is given. Maybe the data itself is true, but it is represented, visually represented, in a false manner, or not just false, or it has its purpose to mislead us. And that's what I want to show you. And that's why you need to be statistically literate to know and take with a grain of salt everything that is given specifically in statistics. There are some studies, I'm not going to go through them, but there are, if you want to find them on the internet, you can easily find them, which tell you that there is more than 60% chance, if there is a chart in a certain news article, that people are going to automatically believe it, no matter what this chart shows. Okay? And this is something that is not good. There should be less than 50%. There should be less than 25% of the people that read the article and then believe it just because of the given statistics. People tend to believe the statistics just because it's statistics. And why do they believe it? Because they think that's math, and they don't know the math that well. Now, considering that you guys yourself mostly think that math isn't that hard, you should be already literate enough to know and take with a grain of salt any given data that appears. Okay, returning to school. It's going to be simple. I'm going to select the returning to school table, and let's see what Excel recommends us. Again, similar to the gender, it will recommend us a column, it will recommend us a row chart, and it will recommend us a pie chart. Any of these three is a good representation. So just so we have, and then it's going to show us also the funnel chart. Okay, why not? And let's go through the last table, and it is going to be how hard is math. We can also hear it here. And it gives us multiple multiple charts as visual representations. Okay, column chart is okay here if you want to know again specific number of peoples with each category. Well, I would say in this here table, the pie chart would be the best representation to tell us what is going on. So we can say that more than 50% of the people say that it is fairly, mathematics is fairly easy in this class. There is a couple of specific people with the orange. Now the colors themselves can change, and you can change the colors. I'm going to show you. Let's put it in so I can show you. Okay, then you can change the colors. Here we have the colors options. Now we have more distinct colors. There you go. And then you can see that if you want to combine answers, how fairly easy and really easy it is, there is almost 2/3 of the class that think that mathematics is really easy. So it's also a nice representation. Okay, let me go back to the table because I'm not done with it, and let's go to recommended charts, a couple of more recommended charts, and there we go. Now again, you have a scatter chart and the line chart. Well, what's the difference between these two? Scatter chart also shows you the points, specific points for each category given. There is an issue with that. It shows you option 6 on option 0, where they don't exist and they're not even given in the questionnaire. So there is a possibility you have to arrange it a little better. Well, line chart is okay, but it shows you basically the trend. And this is another use of the line chart. A line chart shows you the trend, how things are going again. So in this here case, well, you don't have any trend. Oh, there is no, they're like, people didn't like math and people liked it, and they liked it even more than liked it the most. And then it went a little bit down. It's not good representation in this here sense, but in general, you can use line chart for the trends. Okay, now I'm going to give you all of this. You can play with it. Those of you that have already learned things about Excel, you can try and use it for other stuff. And today's double lesson was just to show you simple visual representation of data, simple representation of data. Next week, we're going to continue on. We're going to continue on with the numbers in statistics. And they are going to be called the average values or specific values for statistics, and we're going to go through them. There are a couple of averages. There is not just one type of average in mathematics, or specifically, sorry, in statistics, and we're going to go through it, and you're going to see what's going on. And you have already been using it, these averages. Now, this here column is averages that you already know how to find. Okay, thank you guys for listening. There is no specific homework and that you have something to do. Just write things down so you know how differences, for example, between a pie and a column chart, so you can know which you can use when for your purposes sometime in the future. And that's pretty much it. You can play with this. You can do whatever you want for the next lesson. See you guys.